So this section is going to be part of study assignment B. We're going to focus on our Lewis structures that have more than one central atom. So multiple Now, multiple central atoms can be a little bit tricky to identify. And what you're looking for with multiple central atoms is you're looking for several different atoms that have the opportunity to form multiple bonds, where we might not be able to choose the difference between. Now, in general, what you want to do is when you see a structure or a molecular formula, you want to go ahead and assume that your first atom is going to be your central one, except for hydrogen, because hydrogen can never be a central atom. The other part is that you really should know why. Why is the first atom our central atom? And what you're looking for is you're looking for the lowest group number. And if they have the same group number, then you're looking for the lowest electronegativity between them. What that means is that if we have a molecule with sulfur and oxygen, we normally write something that looks like SO2. The reason why it's SO2 and not O2S is that sulfur and oxygen both share the same group number. They're both in the in group 6A. Now, between sulfur and oxygen, sulfur has lower electronegativity, and so that's why we're putting sulfur in the middle. We end up with our oxygens on the outside for their bond skeleton. For multiple central atoms, you end up with something similar to that. You basically are trying to write out your best Lewis structures with your bond structures. And because of the limitations of how many bonds we can form, then we might have to form this central atom, or these multiple central atoms. So an example of this is going to be C2H6. C2H6, if we only have one central one, that would be a carbon connected with 6 hydrogens and another carbon. And there's just no way that one carbon can make all 14, or all of those 7 bonds to have 14 valence electrons. So we can't do it like that. However, we do have this carbon here, or second carbon, that can form its own grouping. So maybe instead we would have a carbon connected to a carbon, and each of those carbons could have 3 hydrogens around it. Now, carbons are one of the most common ones to make a chain or have multiple centrals because they can form so many bonds. You can still have things like double bonds or triple bonds inside of your carbon, even if you have multiple centers. So you can use this for things like C2H4 and C2H2. Both of those are ones that have multiple centers. Now, your book talks about it a little bit, but as you start making these changes, it's okay for them to have multiple connection options, right? That's something that we'll address in Chem 121 when you start to get into your organic chemistry. And so as long as your bond skeletons hold true, then that's going to be okay. You still want to minimize your formal charges. You still want those electrons to be focused on the more electronegative atoms, but there could be more than one option for how you could draw them out based on their Lewis structures. So you just want to choose the one that makes the most sense. The only option right now that you don't want to do is don't make 3-membered rings. So that's like a carbon connected to a carbon. That looks something like this. Because 3-membered rings are actually very rare to do. Instead, it would be better if we just had a double bond and we had kept it as a straight chain, something like that. And so that's going to be our central or multiple central atoms.